This is Note-Taking Guide 2.4. We're going to write polynomial functions from their roots. So this particular problem right here asks me to write a polynomial function that has roots of x minus 1, x minus 2, and 3. So what we're going to start doing is we're going to put them back inside the parentheses. The negative 1 will go back in as x plus 1. The negative 2 will go in as x plus 2. And that positive 3 will go in as x minus 3 because they always come out as the parentheses as the opposite. So what I need to do now is I need to multiply these together and combine like terms. I'm going to only do two of them at a time. So I'm going to do x times x to get x squared, x times 2 to get 2x, 1 times x to get 1x, and 1 times 2 to get 2. Combine those like terms together here in the middle. So I get x squared plus 3x plus 2. I'm going to put my parentheses back around that because I still have to multiply that by this x minus 3 right here. And I'm going to put that x minus 3 in the front. I just like the way it looks better in the front. And then I'm just going to start multiplying again. So here we go. X times x squared is x cubed. X times 3x is 3x squared. X times 2 is 2x. Then I go to my negative 3. Negative 3 times x squared is a negative 3x squared. Negative 3 times 3x is 6x. And negative 3 times 2 is plus 6. If you notice, I stacked my like terms together. I like to do that so I can just add straight down. So when I do that, here I get x cubed. Here my x squareds cancel, so I have x cubed plus 8x from the 2 and the 6 right there, plus 6. That is how I write a polynomial function given those roots. The next example here says write a polynomial function that has zeros of 1, 3, and negative 5. Again, zeros, roots, solution, those are all the same thing. So those are my answers, my x-intercepts for my graphs here. I'm just going to put those back in the parentheses as their opposites. So x minus 1, x minus 3, and x plus 5. And I'm going to start my multiplication. I'm going to do the first two together and then bring that x plus 5 down when I'm done. X times x is x squared. X times a negative 3 is a negative 3x. Negative 1 times x is a negative 1x. Negative 1 times negative 3 is a positive 3. Combine those like terms together in the middle and you'll have x squared minus 4x plus 3. And then don't forget you got to bring that x plus 5 down. I like to put it in the front just because it looks nicer out there. I like to use it out front, and then I'm just going to start my multiplication all over again. X times x squared is x cubed. X times negative 4x is a negative 4x squared. X times 3 is 3x. Start with your 5. 5 times x squared is 5x squared. I'm going to stack those again. 5 times a negative 4x is a negative 20x. And 5 times 3 is 15. I'm going to stack those, or add them straight down the way I stacked them. So I get x cubed plus 1x squared minus 17x plus 15 for my solution. This time it wants us to write an equation in standard form, meaning from highest power to lowest power, looking at the graph. So again, if you remember, I've said that our x answers are our x-intercepts. They're also called roots and zeros. So if this one's at negative 2, this one's at 3, and this one's at 7, when I put those back into my parentheses, I'm going to write that as x minus, the minus 2 becomes x plus 2. The x right here that's equal to 3 would be x minus 3, and the x value that's 7 would be x minus 7. And again, I just start multiplying. X squared minus 3x plus 2x minus 6. Combine like terms in the middle, and you get x squared minus x minus 6. I'm going to bring that x minus 7 down in front and just rewrite that so I have a little bit more space, and keep multiplying. X times x squared is x cubed. X times negative x is a negative x squared. X times a negative 6 is a negative 6x. Negative 7 times x squared is a negative 7x squared. Negative 7 times negative x is a positive 7x. And a negative 7 times a negative 6 is a positive 42. I stacked those so I can add them straight down. I get x cubed minus 8x squared plus x plus 42 for my equation to the polynomial that has that graph. This one is set up exactly the same way. I'm just going to help you get this one set up and then move on to our next problem. Again, what we do is identify our x-intercepts. This would be at negative 2, positive 1, and 4. We put them back into the parentheses as their opposites. And we really just start multiplying. And I need to go back and erase that. I accidentally put a plus sign here, and it needs to be a minus sign. So start multiplying this one, and if you want to know the correct answer to that, just come and check with Mrs. Clark. I'll be happy to show you the answer. This next example is talking about multiplicity. So it says we have 3 roots of a cubic function. We have x equals 0, negative 3, and negative 3. Meaning that the polynomial function has the same answer twice, or has a multiplicity of 2. And this time a leading coefficient of a negative 1/3. We're going to take care of that leading coefficient part at the very end. But what we're going to do is we're going to write this out with our roots. I want to take a minute up here and just show you that if I put x in with my 0, I could do x plus 0 or I could do x minus 0. It doesn't really matter. It's really just x. So when I write my 0 value, I'm going to just put x because x plus 0 kind of looks funny. Then I'm going to have x plus 3, and that's going to happen twice. So I really just start multiplying this. Pick 2 of them, multiply them together. So you have x squared plus 3x. And then you're going to take that and multiply it through the third one. So it's a FOIL problem from here. So x squared times x is x cubed. X squared times 3 is plus 3x squared. 3x times x is another 3x squared, and then 3x times 3 is a plus 9. I'm going to add those together straight down, and I'm just going to bring my answer up over here so that I have a little bit more space to work. So that adds together to be x cubed plus 6x squared plus 9. Now I'm almost done with this because this is a polynomial function that has those roots. But the thing that I'm missing is that my leading coefficient is not a negative 1/3. The number that's out here is a 1. In order to get it to be a negative 1/3, I'm going to have to multiply that entire equation through by a negative 1/3 in order to get that to work. So I'm just going to put here that I'm multiplying here by a negative 1/3. When I do that, I get a negative 1/3 x cubed. And then a negative 1/3 times 6 would be a negative 2. And a negative 1/3 times 9 would be a negative 3. So what I did was I just times this entire equation up here through by my negative 1. This next problem has the same kind of thing. It has a multiplicity going on. So it has the polynomial function that has 2 unique roots, 2 and negative 1. And then it says negative 1 has a multiplicity of 2. So if we were going to write that out, the 2 goes back in as x minus 2. And then I have x plus 1 from the negative 1. And I have it twice. Okay. This time my leading coefficient is 1. So as long as when I'm done multiplying this, the leading coefficient is 1, I get to be done. I pick 2 of them and I multiply them together. So x times x is x squared. X times 1 is 1x. And then a minus 2x. And a minus 2. Combine those like terms together in the middle and get a negative x minus 2 right there. Then I'm going to bring that x plus 1 down. I like to put it in front, but you can put it in the back. And then just multiply again. So x times x squared is x cubed. X times a negative x is a negative x squared. X times a negative 2 is a negative 2x. 1 times x squared is x squared. 1 times x, negative x is a negative x. And 1 times a negative 2 is a negative 2. We're going to add these straight down now to get our equation. We have x cubed. The x squareds cancel each other out, so they're gone. Minus 3x minus 2. Because my leading coefficient out front is already a 1, which is what it said it had to be, I'm done right there. So the big question is, what does that multiplicity mean? Well, the interesting thing is when we have a multiplicity of 2 or 4 or 6, an even number of multiplicities, our graph actually touches the x-axis there instead of crossing the x-axis there. So because my graph is touching at negative 2, I know when I put it back in parentheses, I have a multiplicity of 2 there. So I'm going to do x plus 2, x plus 2 because it's at negative 2. And then because this one's at positive 2, I'm going to have x minus 2. So again, we're going to multiply these together, and I think I've shown you plenty of those examples. You're just going to multiply these two together, get that answer, and multiply it by the third one. And again, if you want to see the answer to this problem worked out, you're welcome to come and check Mrs. Clark's notes out. The next example says write an equation for a quartic. So quartic means a power of 5 or degree of 5 polynomial with zeros at negative 2, 0, 3, and 4. And I just said power of 5, and I really meant power of 4. Sorry about that, you guys. Sometimes I get all mixed up. Quartic is 4. So we have zeros at negative 2, 0, 3, and 4. So we're going to put them back in our parentheses. The x minus 2 goes in as x plus 2. The x equals 0 just shows up as an x because remember before we said x plus 0 just kind of looks funny. The 3 goes back in as x minus 3, and the 4 goes in as x minus 4. Again, we're going to multiply this out. So it's going to be a lot of multiplying here. We're going to do these two together and get that answer. So x squared plus 2x. Then multiply it by the next one. And then we're going to save this one for a little bit later. So x squared times x is x cubed. X squared times a negative 3 is a negative 3x squared. 2x times x is 2x squared. And 2x times 3 is a minus 6x. We're going to combine those together to get x cubed minus x minus 6x. And I still have to multiply that through here by the x minus 4. And sometimes I like to put that in the front and multiply. Sometimes I like to put that in the back and multiply. It doesn't really matter. The x is coming here, here, and here. And then the 4 is coming here, here, and here to get your solution. So you're going to get x to the 4th from the x times the x cubed. And then minus x squared. And then minus 6x squared. And then we're going to have minus x squared again. So I'm on the 4. So I'm going to have, sorry, this was x to the fourth, x squared, minus 6x squared. Now I'm on the 4, so it's minus 4x cubed. I'm just going to erase that and write it again. Minus 4x cubed, and then minus 4x, and then minus 24x. Shoot, I keep wondering why this is not working right for me, because in my brain it's not working right, and it's because I left a squared off right here. So I'm going to have to go back to where I was. Oh, I should not have erased this part. But we're going to go back up here and start multiplying all over again. Guys, don't lose your powers. It's never fun when you do. So again, this is x cubed plus 2x squared minus 3x squared minus 6x. Combine your like terms here, which are those x squareds in the middle, and you get x cubed minus x squared minus 6x, and we still have to bring down the x minus 4. So you have x cubed times x, which is x to the fourth, x cubed times 4, which is a minus 4x cubed, negative x squared times x, which is a negative x cubed, negative x squared times 4, which is a positive 4x squared, negative 6x times x, which is a minus 6x squared, and a negative 6 times a negative 4, which is a positive 24x. I'm going to go off theme here. I'm going to keep combining like terms here. My highest power is 4, and I only have one of them. On my x cubes, I have a negative 5 of them. On my x squareds, I have a minus 2x of them, and then plus 24x. That one was really messy. I'm sorry that I messed that up in the middle. Don't lose your powers. That's the key right there.